Hello, my dear students. My name is Sudhir Kumar, a lecturer in Mechanical Engineering in GEMS Polytechnic College, Aurangabad, Bihar. So today we will see lecture 4 from Unit 1. Our Unit 1 name is Simple Stresses and Strain. So throughout this lecture, we will mostly focus on few topics. So our content of the lectures are following. First one, longitudinal strain. Second one, lateral strain. Third one, Poisson's ratio. And fourth one, volumetric strain. In volumetric strain, we will see three subtopics. First one, volumetric strain for uniaxial loading. Second one, volumetric strain for biaxial loading, and third one, volumetric strain for triaxial loading. My dear friends, I hope you must have a clear understanding about strain, because strain is very simple term. What is a strain? Change in dimension by original dimension, or change in length by original length is known as a strain. So today we are going to see the various types of strain. So we will start with longitudinal strain. Actually, when a body is subjected to an axial tensile load, there is an increase in length of the body, but at the same time there is a decrease in other dimension of the body at right angle to the line of action of the applied load. Thus, the body is having axial deformation and also deformation at right angle to the line of action of the applied load. Understand? So, the ratio of axial deformation to the original length of the body is known as longitudinal strain. Understand? Longitudinal strain means the ratio of change in length to the original length in simple word, and it is denoted by E longitudinal. Longitudinal is simply written as LON, simple word. So E longitudinal, understand, it is denoted by E longitudinal. And one more thing you have to always keep in your mind while solving the numerical problem, because it is also called as linear strain. Understand? So don't get confused while getting this term. So linear strain is the strain as longitudinal strain. Understand? So longitudinal strain and linear strain is the same. Then if you will see mathematically, longitudinal strain, E longitudinal strain is equal to dl by L. That means change in length to the original length. Understand? Change in length to the original length. Now we will see next slide. Lateral strain. So now we will see lateral strain. Understand? So the strain at right angle to the direction of applied load is known as lateral strain. Understand? In other words, a strain in perpendicular direction to the longitudinal axis is called lateral strain. Or what I told you in simple word, the strain at right angle to the direction of applied load is known as lateral strain. So lateral strain is denoted by E lateral. Lateral strain is denoted by E lateral, and longitudinal strain is denoted by E LON, E longitudinal, and lateral strain is denoted by E lateral. Understand? And lateral strain is equal to dB by B, or lateral strain is equal to dD by D. Now we will see our next slide, which is Poisson's ratio. What is Poisson's ratio? Poisson's ratio is very important during solving all the numerical problem in engineering material. Understand? So what is Poisson's ratio? The ratio of lateral strain to the longitudinal strain is known as Poisson's ratio. Understand? Here we will see Poisson's ratio is the ratio of lateral strain to linear strain. Yes, one more thing you have to understand. linear stress. Here linear stress is same as longitudinal strain. Understand? So linear strain is the another word for longitudinal strain. So don't get confused while solving numerical problem. If there will be linear strain, then you have to consider that linear strain as longitudinal strain. Or if there will be longitudinal strain, then consider that longitudinal strain as linear strain, because both terms are same only. And the Poisson's ratio is denoted by mu. Understand? Once again I will repeat, Poisson's ratio is the ratio of lateral strain to linear strain or lateral strain to longitudinal strain. If you will see mathematically Poisson ratio is equal to mu is equal to lateral strain divided by longitudinal strain. Understand? See, minus sign is used to show Poisson's ratio as positive number. Understand? Then one more thing. For engineering material, the maximum Poisson's ratio will be 0.5. Understand? The maximum Poisson's ratio will be 0.5 and minimum Poisson's ratio will be 0. So we can say as the minimum Poisson's ratio for any engineering material is equal to or greater than 0. Understand? So Poisson's ratio, see, now we will see some Poisson's ratio for some material such as cast iron. Cast iron Poisson ratio is between 0.21 to 0.29. Second one, mild steel. For mild steel, Poisson ratio is 0.28. For concrete, Poisson's ratio is 0.2. For glass, Poisson's ratio is 0.25. For copper, Poisson's ratio is 0.27. For brass and aluminium, Poisson's ratio is 0.33. And for cork, Poisson's ratio is 0. Once again I will repeat. What is Poisson's ratio? Lateral strain divided by longitudinal strain or lateral strain divided by linear strain. Understand? And Poisson's ratio will be from 0 to 0.5. It will not exceed 0.5. Understand? Next we will see volumetric strain. What is volumetric strain and what are the types of volumetric strain? This is very important. Understand? So we will see now what is volumetric strain. So what is volumetric strain? The ratio of change in volume to the original volume is called as volumetric strain. Understand? The ratio of change in volume to the original volume. That means formula will comes like this. EV is equal to del V divided by V, where del V is equal to change in volume, V is equal to original volume, and EV will be known as volumetric strain. Why? Because we are denoting a strain as a small e and we are putting V as volumetric. So this will be E, V will be known as volumetric strain, and volumetric strain is equal to del V by V. That means change in volume divided by original volume. Understand? We will see next slide. Actually, volumetric strain has three types or three parts. First one is volumetric strain for uniaxial loading. If our loads are in only one direction, then it is known as uniaxial loading. Understand? Axial loading. Understand? So for uniaxial loading, volumetric strain is equal to del V by V is equal to sigma x divided by E into 1 minus 2 mu. Understand? Where del V is equal to change in volume, V is equal to original volume, and sigma x. What will be sigma x? A stress in x direction. That is very important. X denote the direction of a stress. So here the stress will be in x direction. Understand? Here see load is from this direction, and load is from this direction. So our stress will act in x direction. So formula will comes like this. For uniaxial loading, that means only in one direction. Understand? For only in one direction loading, the formula is like this. Sigma x divided by E is Young's modulus 1 minus 2 mu. Mu is Poisson's ratio. What is Poisson's ratio? Lateral strain divided by longitudinal strain. So this is our uniaxial loading for volumetric strain. Understand? These things you have to keep in your mind. This diagram and this formula, because formula you have to use in solving numerical problem. Second things we will see, volumetric strain for biaxial loading. Before we seen uniaxial, now we will see biaxial. Biaxial means in two axis strain will act. Here see, in y-axis also strain is acting, in x-axis also strain is acting. So for this one, our formula is like this. We will combine stress of x-axis plus stress of y-axis divided by same thing, divided by Young's modulus into 1 minus 2 mu. Mu is Poisson's ratio. What is Poisson's ratio? Lateral strain by longitudinal strain. Understand? So here also you have to keep this diagram and this formula in your mind to solve numerical problem. Now we will see volumetric strain. Now we are going to see volumetric strain. What is volumetric strain? What is volumetric strain? Change in volume divided by original volume. Change in volume divided by original volume. And we are now seeing the types of volumetric strain. First we have seen volumetric strain for uniaxial loading. Then we have seen volumetric strain for biaxial loading. Now we are going to see volumetric strain for triaxial loading. That means the strain will work in three directions. First one is x direction, second one is y direction, and third one is z direction or z plane. We can say x plane, y plane or z plane. Understand? So here a strain will act in all three planes, x plane, y plane and z plane. So how our formula will come here? Same things. Volumetric strain is called as del v by v. Understand? It's equal to, now we will add all the stresses. This stress for x-axis, x plane, this stress for y plane, and this stress is for z plane. So we are adding sigma x plus sigma y plus sigma z. Understand? Divided by E. E is Young's modulus into 1 minus 2 mu. Mu is Poisson's ratio. Understand? So these are the formulas which we will use to solve numerical problem. So keep these things in your mind. Okay, I will erase it so that you can copy the notes in a proper manner. See, one more thing I will tell you, my dear students. Please make notes of all the lecture. Understand? We are teaching you through PPT for your benefits purpose only. Why? Because you can easily get all the notes from our PPT. So don't misuse it. Study daily at least 1 hour or 2 hours. Understand? Next we will see summary of today's lecture, or we can say we will summarize all the things which we learned throughout this lecture. So first we will start with our longitudinal strain. What we have seen in longitudinal strain? When a body is subjected to an axial tensile load, there is increase in the length of the body, but at the same time there is decrease in other dimension of the body at right angle. Understand? To the applied load. So the body is having axial deformation and also deformation at right angle to the line of action of the applied load. So the ratio of axial deformation to the original length of the body is known as longitudinal strain. Or one more thing, I have said you longitudinal strain is only known as linear strain. Understand? Longitudinal strain is only known as what? Linear strain. Again, we will see lateral strain. What is lateral strain? Now we will summarize everything. What is lateral strain? The strain at right angle to the direction of applied load is known as lateral strain. Once again, I will repeat it. The strain at right angle to the direction of applied load is known as lateral strain. Now we will see Poisson's ratio. So Poisson's ratio will comes from these two strain, lateral strain and longitudinal strain. So what is Poisson's ratio? Poisson's ratio is denoted by letter mu, and it is the ratio of lateral strain divided by longitudinal strain, or we can say as lateral strain divided by linear strain. One more thing I will make you clear, the Poisson's ratio mu has no unit. Why? Already I have told you strain has no unit. Why? Change in length by original length. Strain is change in length by original length. So meter get cancelled, or centimeter get cancelled from bottom and bottom and top. That means from numerator and denominator the same unit get cancelled. Understand? That's why strain has no unit. If strain has no unit, that means Poisson's ratio also don't have any unit. That means Poisson's ratio is also dimensionless. Understand? Now we will see volumetric strain. What is volumetric strain? The change in volume divided by original volume is known as volumetric strain. Once again I will repeat it. The change in volume divided by original volume is known as volumetric strain. See, one thing I will tell you. If you will have the clear concept about strain, then you must have clear concept about longitudinal strain, lateral strain, Poisson's ratio and volumetric strain, because all these things comes from strain only. So you should have a clear concept about strain. Understand? Then there are three types of volumetric strain. First one is volumetric strain for uniaxial loading. That means if the stress will act only in one plane, like x-axis. Second thing, volumetric strain for biaxial loading. That means the strain will act in two axes or two planes, such as x plane or y plane. And the third one is volumetric strain for triaxial loading. That means the strain will act in x plane, in y plane and in z plane also. Understand? So these are the things which we have studied throughout this lecture. So I hope you must have got a clear concept about the following terms. Next things, reference. So if you want to get more knowledge or more ideas about the particular topic, then you may refer these books. First book is Strength of Material. The author name is Dr. R.K. Bansal and the publisher is Dhanpat Rai and Son. And second book is Mechanics of Solid and author name is R.S. Khurmi and publicator name is S. Chand publication. Understand? So I will suggest you these two books. Understand? If you will follow these two books or these two authors, then easily you have a clear concept about the particular topics. Actually, if you will see these two books, actually they used to provide lots of numerical problem on particular topics, each and every particular topics. So you must focus on this reference. Understand? What? First one is Strength of Material book and second one is Mechanics of Solid book. It is written by Dr. R.K. Bansal and second one is written by R.S. Khurmi. So you can get these books from our library also. Whenever you are getting free time, you can get from our library, or some things you can learn in an effective manner. So my dear students, please focus on this particular topic. These topics are very easy, but if you don't study these easy topics, then you will be not able to solve numerical problem. Understand? This is our last slide. That means thank you. From my side, I am telling you thank you. This is our lecture 4, which comes under unit 1, simple stresses and strain. So my dear students, please study in an effective manner, and if you have any types of doubt, please contact me in comment, or you can contact me personally also. Thank you.